So in the screen, there is JEE Advanced 2019 paper 1 question of capacitor. Firstly, read the question. A parallel plate capacitor of capacitance C has a spacing D between the two plates having area A. The region between the plates is filled with N dielectric. They are parallel to it. Plate each having thickness delta is equal to D by N. The dielectric constant of mth layer is Km is equal to K1 by M1 plus M by N for a very large N that is greater than 1000. The capacitance C is mu K epsilon A by D ln of 2. Find the value of mu. So we will proceed solving this question, and we can solve this question by taking element of dx from x distance from one plate, but we can also solve this question by using limit as a sum of integral. So we will proceed solving the question by the same method. So the capacitor will look like this, and there are in such type of plates inserted, for which means if we take these, and its dielectric constant Km is given by K1 plus M by N according to the question. Hence we will proceed by taking a simple observation. For example, we know that the formula of capacitor having dielectric constant K is given by K epsilon naught A by D. The formula of capacitor is given by this. Since we will take this as one capacitor, hence the total capacitor we have is N according to the question. And also this capacitor can be considered connected in a parallel like this. So we will get 1 by C equivalent is equal to summation of 1 by K epsilon naught A by delta, where delta we have been provided in the question as D by N. Here is what delta is given as D by N. Also we have been given K is equal to 1 plus M by N. So in the next step we will next step 1 by 1 plus M by N epsilon naught A by delta we will, and M from 0 to N according to the question. M is from 0 to N. We will take all the constant outside the sigma, and C equivalent can be written as delta by epsilon naught summation M is equal to 0 to N and 1 by 1 plus M by N. Here delta is D by N, and hence we will write it as D by N. C equivalent is equal to D by N epsilon naught A, and summation 0 to N 1 by 1 plus M by N. We will take N inside the sigma, as N is constant we can write it as 1 by N in the sigma. And now by using limit as a sum of integration, we can write M by N as X, hence N will become dx, and sigma 0 to N becomes integral 0 to 1 by C equivalent can be written as D by epsilon naught A 0 to 1 by 1 plus X dx. And we know that the integration of this is ln 1 by C equivalent can be written as epsilon naught A 0 to 1 ln 1 plus X. This is the integration of this, and now we will put the limits and we will get the answer. C equivalent can be written as epsilon naught A, and if we put the limit we got ln 2 minus ln 1, which will become 0 eventually. And now we will we will get 1 by C equivalent is equal to d by epsilon naught A ln of 2. Hence C equivalent will be equal to epsilon naught A d ln 2. And in the question it is given that C is equal to mu k epsilon A by d ln 2. Sorry, we have forgot here, there should be k, so we'll take in account of k. So we will manage k outside this, and here eventually k and k will come upon k epsilon naught A d ln 2. So in the question it is given that C equivalent is equal to mu k epsilon A by d ln 2, and we have the answer this. Comparing these two, we will get mu is equal to 1, so 1 is the answer.